All right, ladies and gentlemen, welcome everybody. Thank you. And on behalf of everyone here, I'd like to thank you all for coming out to the second annual World Conference here at Nagios. Up next, we're going to have Alex Solomon, co-founder and CEO of PagerDuty. Why don't you go ahead, give him a big round of applause here.
Thank you. Hi guys. I'm Alex, and I'm here to talk to you today about managing your heroes. So the people aspect of monitoring. And it's a focus on dealing with outages and failures, as well as the kind of human element to that. So by way of introduction, I am one of the co-founders and CEO of PagerDuty. PagerDuty, we have a product also called PagerDuty, which does on-call management and alerting for IT ops. So kind of handles alerting and when some plugs into your monitoring tools. When something goes wrong, like your servers or websites or anything like that go down, we will alert the right person so they can fix the problem. We also handle on-call scheduling and escalation and stuff like that. And I've been working on this for just about 3.5 years, and I've been thinking about on-call procedures and best practices for even longer than that. So before that, I worked for a company called Intersect, building e-commerce websites. And before that, I worked at Amazon.com over in Seattle as a software engineer. This is where I was first introduced to on-call, actually. What Amazon does is they actually put all of their engineers on call. You have to wear a pager on your belt. It's called being on PagerDuty, unsurprisingly. That's where we kind of got the idea for PagerDuty as well. So before we just dive right into it, I'd like to go over a few quick definitions. One of which, I'm sure you guys are already familiar with a bunch of these, but one of which is a service level agreement, or SLA. This is a contract between you or your company and your customers or users, which defines the level of availability that you're going to offer to your customers. It's typically defined in terms of an uptime guarantee. For example, 99.9% uptime guarantee. That means you need to be up that amount of time, or you can only go down 0.1% of the time. Another one of these is mean time to resolution, MTTR. This is actually a very, very important ops metric. It kind of defines how quickly you resolve outages from the time that they are detected to the time they are fully fixed on average. And closely related to that is mean time to response, which is how quickly your team or your on-call people respond to outages. Mean time to response is actually a subset of mean time to resolution. So if I can give you an analogy, imagine your building's on fire and you just call 911. Your response time, or the response time of the firefighters, is measured from the time that you made the call till the time that they actually show up at your doorstep. And the resolution time is the total time from the 911 call until they actually put out the fire. And then last but not least, we have mean time between failures. This gives you a sense of how frequently outages or failures happen. So if you have an MTBF of 1 month, that means that on average you go down once a month. So let's talk a little bit about outages. Can we prevent them? As you know, an ounce of prevention is worth a pound of cure and all that. So there's various things you can do to prevent outages. One of which is look for single points of failure. Look for single points of failure in your infrastructure. So, and then to fix that, you have to add or engineer your systems such that they're redundant. Let me give you a simple example. Let's say you have a MySQL database. If you're just running a simple one server setup with just the one master database, that's a single point of failure. If it goes down, what do? Well, you have to restore from backup, or try to get the server back up or something like that. You're kind of screwed. So what you want to do to eliminate that is examine how much downtime is acceptable for you, and also look at whether it's okay to have some data loss or not, and then set up a replica. That's one common scenario. So if you're okay with 10 to 20 minutes of downtime, do a replica, and then set up a process whereby you promote that replica to the master and you do a flip. If your uptime requirements are actually more stringent, kind of like in the 1 to 2 minute range, which is the case for us, that means you can't use MySQL in the first place. And another cause of outages is big, complex, monolithic systems. By this I mean systems that are very tightly coupled, where you change one little thing here and then something breaks over here. And part of the reason I bring this up is because PagerDuty started as a big monolithic system on top of MySQL. And we've ended up with cases where we change something in the billing system and it would break reporting. So we're now working on taking that big system and dividing it into components and moving to a service-oriented architecture. So we're taking our system and breaking it up into services, which are independent stacks, which talk to each other via APIs. This is a pretty common practice, actually. Amazon does this, Netflix does it as well. For example, here is a diagram of Netflix's distributed SOA architecture. So each one of those boxes is a service, and all the lines are how they talk to each other. And another factor of preventing outages, or of cause of outages, is change. So systems that change a lot generally have more problems or failures. Conversely, systems that rarely change or never change it can be made to be fairly reliable. So think the telephone network. It actually achieves 5 nines reliability, 99.999% uptime. Unfortunately, there's not much you can do about this. I mean, presumably, you're developing a business. You're building new stuff. You have customers who want new features. So you have to push the envelope forward. You can't just freeze your system at one point in time and say, okay, that's it. We're not changing it anymore. So ultimately, while there are many things you can do to kind of reduce outages and reduce downtime, failures are just going to be a common fact of life, and they will happen. So you have to start thinking about how to deal with them, how to mitigate them, and how to quickly respond to them instead of kind of burying your head in the sand and saying, we will never have any outages. So this brings me to the failure life cycle. This starts with monitoring at the top. Actually, I feel that as a community, we put a lot of emphasis on monitoring. We talk about monitoring large-scale infrastructures. We talk a lot about metrics and dashboards and correlating failures together. And this is really good. However, it feels at times like we don't consider the rest of the life cycle enough, like how to deal with outages when they happen. And this is kind of the reason why I'm doing this talk. So at a high level, the failure lifecycle is actually pretty simple. You start with monitoring. Your monitoring tools look for various failures across your infrastructure. At some point, a failure will occur and will be detected by monitoring, and an alert will be kicked off to your ops engineers. The ops engineers will investigate the issue, and they will eventually fix it after much trial and tribulation. Now, a good ops or engineering team will have an extra very critical step in this pipeline. This is called the root cause analysis step. So you do this after the problem is fixed, and you start digging deep, and it's a little bit like detective work to figure out why the problem happened in the first place. And then, of course, after you do your analysis, there should be a critical feedback loop such that you implement improvements in each one of the stages. If your monitoring was broken in some way, you improve it. If your alerting processes or your alerting systems need some work, you improve that as well. You improve each one of the steps and processes as well. It's not just tools, it's also about the processes. So I can go into a little bit of an example here. Let's say you're running a web application and it goes down. So your monitoring detects it, of course, and it kicks out an alert to the ops engineer. The engineer gets woken up and goes and starts debugging the problem. He sees, oh, it's the primary database is down. Okay, let's do a flip to the backup. So now, after a while, the problem is finally fixed. The backup is now the primary, and it's time, during the day, not in the middle of the night, to do the root cause analysis. So in this example, let's say the root cause analysis shows that the database primary was out of disk space. So what's the problem? Well, number one, your monitoring system didn't detect that. So we need to go back and start implementing some disk-based monitors across not just the database server, but all of our servers. I mean, we made the mistake once. We don't want to make it for other servers. At the alert stage, in this case, there was a problem in that the person, it took them 30 minutes to respond to the alert. Well, that's kind of a long time. It's 30 minutes of wasted downtime there. If the person had responded within 5 minutes, you could have saved 25 minutes on that outage. So what you want to do there is look at the reasons why. Let's say the person only got SMS alerts and slept through a whole bunch of them. Well, you want to add some phone calls or give him a pager such that he responds much faster. Looking at the next stage, the investigation stage, the person didn't have the tools required to debug the problem. What he did was he saw that the database was down and instantly reached for the flip process, which is a time-consuming process. If he had realized that it was a disk space issue, he could have logged into the server and deleted some, freed up some disk space. So you want better tools and dashboards to kind of show you that these problems are occurring in the investigation stage to speed that up. And finally, the fix stage, the flip process, let's say in this case, took 20 minutes, and there was some trial and error involved as well. Well, you can look at ways to improve that as well by automating it or by writing a better guide, a step-by-step guide on how to do it, by making sure that all of your ops people are practicing these things, that they're not just thrown in the deep end and are expected to just do a database flip just based on a guide. So let's also look at the critical incident timeline. This is the period of time between the time that an issue is detected and that an issue is fixed. So there's three major components to this. There's the alert stage, which is the time from when the issue is detected to when the engineer starts working on it. There's an investigation stage where they're frantically doing research and trying to figure out what's going on. And there's also a fix stage where they're actually implementing a fix. So the first part is the alert part, which you can see there. And the time between the issue is detected and the engineer starts working on the issue is called the response time. This is where that mean time to response metric comes in. And then we have the investigation stage where the engineer is kind of logging in, trying stuff, debugging, and trying to figure out what the problem is. The line between investigation and fix is actually fairly blurry because oftentimes it's a trial and error process. You're going to try different fixes and see if they work, and then finally something will work and the problem is fixed. Obviously, you're in a mad rush, you're in a panic trying to fix the problem as quickly as possible to reduce the downtime. You don't have time to do careful thinking some of the time. And then the fix stage itself sometimes is very quick and sometimes is very slow. Like, sometimes all it takes is reboot the server or, free up some disk space. Other times you have to do a database flip, which is a long and risky process. Or even worse, you have to do a data center flip in an emergency, which is like really complicated, really risky. So next, we're going to dive more deeply into each one of these stages to see how we can improve the processes and reduce that time. So actually, the total time is the resolution time. That's the MTTR metric, the mean time to resolution. So let's start by looking at the monitor stage. Here is where you actually want to monitor everything, all levels of the stack, starting from the data center, the network, the servers, the database, application, website, and you actually sometimes even want to measure and monitor your business metrics. A good example of this is, let's say you're a big e-commerce, retailer, and you have a steady flow of orders that are over 1,000 an hour, and then in 1 hour your orders drop to 10. Well, you really, really should know about this and start figuring out what's going on. And I mean, a good question is why monitor everything? This is because in a critical failure scenario, you want lots and lots and lots of metrics. You want dashboards, you want metrics in order to fix issues quickly. That's why if it's easy, just monitor it. I mean, you can't have too much metrics. And the tools here, I mean, there's lots of great tools, obviously. Some that you're going to have internal inside your data center and some that you're going to run externally. For internal, Nagios obviously is one of the best. It can monitor various levels of the stack, all the way from the data center, servers, database, network. It can really monitor everything with its extensible plug-in architecture. Another great tool is something like Splunk. Splunk actually slurps in all of your machine-generated log files, and it can run real-time searches for your logs. and it can also do automatic error detection inside your logs. So if you're getting a high rate of errors, it can alert you about that. And guess what? It plugs into Nagios as well. And then you have external tools, which I would recommend that you look into if you don't have anything like this. These are great because sometimes your network goes down, and your internal tools also may go down as well with it. So you want something external that you're not, someone else is hosting, that's software as a service. Something like Pingdom is a very simple one. It monitors your network from the outside and also checks if your websites are up. New Relic is a great one for applications. It detects the health of your apps, your web applications. And then last but not least, you want metrics and dashboards. And there's lots of great tools here too. Something like Graphite, if you're old school, or you can try one of the newer breed tools like Datadog, which is a similar idea, but it's hosted, software as a service. So let's start looking at the alert step of the failure lifecycle. One of the best practices here for alerting is to categorize all of your alerts by severity. The idea here is you really, really, really want, this is actually really important, but you really want to separate your critical alerts from your lower priority alerts. And there's many reasons why you want to do this, but the chief one of which is that you don't want to get paged for the low priority alerts. You don't want to get a phone call at 4 a.m. for a server going down when you have a fleet of 20. So what you really need to do is define severities and make sure that your issues and your failures fit into one of your categories. So I'll show you how we did it at Amazon. We defined the severities based on the business impact. So a Sev1 type of issue was a large-scale business loss. I mean, an example of that would be the actual whole website being down, or a big order drop, like I talked about before. This is a scenario where Amazon loses tens of thousands of dollars per minute. So you want to fix it as soon as possible. A Sev2 is defined as a small to medium business loss. It's also critical. You also need to get people on it right away. Those are the two critical severities. And then the non-critical ones, the 3 and the 4. At a 3, you don't have an immediate business loss, but customers may be impacted. And a 4, no customers are impacted. So like if you have a bug or something like that, that might fit into the 4. And each one of the severity levels should have its own standard operating procedure, or SOP. And it's important to figure out who is notified, how they are notified, and how quickly they need to respond. This is kind of like an internal SLA that you have for your org. And I'll go over each one of the severities. So for a Sev1, these are the major outages, the all hands on deck. The entire data center is down. This is where you want to notify the entire team or even multiple teams via all the methods you have, like phone call, SMS, pager, all of that stuff. You want a very fast response time, something in the realm of 5 minutes. And you want people working on it as quickly as possible. For a Sev2, these are also critical issues, but you don't need like an all hands on deck situation. That's why you have the concept of on-call. You set one or maybe a couple of people to be on call, and you notify them, again, via all the methods, phone, SMS, pager. The response time, you can set it a little more lax as well. You can do something like 15 minutes in this case. And then finally, for a non-critical issue like a Sev3, you can notify, you don't even need to notify the on-call person, but if you do, you can just send them an email, and then you can set a very loose SLA of, take care of it next time you're in the office type thing. So let's look at Sev1 incidents. Now, these are typically very rare. I hope they're rare. They're also rarely auto-generated. And by this I mean that a lot of the time they start as Sev2s, and then they just get worse and get promoted to a Sev1. And if you find that you're getting a lot of Sev1s, that's when, or the mean time between failure for Sev1 is low. That means that you need to start putting some more engineering work into digging yourself out of the hole. For Sev2 incidents, these are more common. They should be mostly auto-generated. If you're finding that that people are opening a lot of Sev2s in your org, that means you don't have your monitoring set up right, because you're using humans to do your monitoring. You want to kind of fix that and automate that process. And finally, Sev3 incidents, these are non-critical. They can be auto-generated. They can be opened manually as well. Like, for example, a bug, a usability bug could fit into a Sev3. An example of this is, let's say you have a fleet of 20 servers. If one of your servers goes down, that's a Sev3 because that's why you have 20. You have the redundancy. You can survive one single server going down. Another thing about severities is they can be downgraded or upgraded as needed. So a Sev2 can actually become a 1 when the problem gets worse, or if the problem was worse to begin with and we didn't realize it, or if you're breaching an SLA by a long period of time. Let's say your SLA is 30 minutes of downtime is okay, and then you need to start giving refunds to your customers. Well, once you reach 30 minutes, maybe it's a 2. Once you reach an hour, maybe that should be upgraded to a 1 because it should have been fixed by now. You want more people to get in and start working on it. And then Sev1s can become 2s as well. A Sev1 issue, once people start working on it, starts getting fixed. And once it's getting fixed, you can downgrade it to a 2 and then continue to fix it until you can downgrade it to a 3. So a good reason for taking a 2 and downgrading it into a 3 is that a critical problem occurs, you fix it, and then you want to leave it open as a 3, kind of like a ticket in your ticketing system, so that you address the root cause analysis, in the morning when you get a chance. And one more best practice: make sure you bias your alertings to happen before your systems fail completely. And by this, I mean I can give you an example. At PagerDuty, we run a Cassandra cluster that's 5 servers. And such a cluster can survive 2 node outages or 2 of the servers going down, and it's still operational. If 3 servers go down, the whole cluster is toast. It's no longer working. So if this is how we work. This is how we define the issues for our cluster. If one single node goes down, that's a Sev3 issue. I mean, the cluster's still operational and it still has redundancy, but we need to fix it to increase the redundancy to the maximum level. If 2 nodes go down, that's when we open a Sev2. Now, if 2 nodes go down, this cluster is still operational and we don't have any downtime. Yet we open a Sev2 because our requirement is that the cluster has to maintain some level of redundancy. If we're running with 2 nodes down, that means we're right on the edge. And one more node going down will cause a Sev1. So really bad situation, really risky. That's why we need to fix it right away, even in the middle of the night. So one of the main benefits, I mean, there's lots of benefits to defining this severity framework for your organization. But one of the big benefits is that it provides a framework that you can use to categorize issues. And more importantly, you make sure that you only page your on-call staff only on critical issues, Sev1 or Sev2. You also want to make sure that you loop in your business owners, your non-technical people, so that they understand this. Because sometimes you can get a business owner who finds a small bug on the website and he opens a Sev1 and wakes up like 10 people, because he doesn't understand that a Sev1 is not required in that case. That should probably be like a Sev3. Fix it in the morning. And if you get this wrong, you're going to have problems. Like you're going to end up going crazy. People are going to get paged all the time for like random trivialities, which is bad. But more likely than that, you're going to end up with like scenarios where you just turn off your phone. Like you keep getting a false alert, and another one, and another one. You're just going to turn off your phone, and then you're going to miss a real outage. So that's the real problem. So let's talk about on-call best practices. You can think of these at the person level. How can I be better at doing on-call? And at the team level, how can we make the team better at handling on-call? So at the person level, I mean, there's some basic stuff here, but you want to have a cell phone so that you can receive phone calls and SMSs. You may also want to get a pager. I don't recommend pagers anymore because we've seen scenarios where the paging system has become unreliable and people are missing pages left and right. I mean, it's a very old system. Nobody's really putting much effort into maintaining it these days. So I mean, it's your own call there. But I've heard bad things about it. And of course, you want to set the ringer to high. You don't want to put your phone on silent. The usual stuff. And even better than a cell phone, get a smartphone. iPhone or Android are both good choices. And don't forget the charger. I mean, these phones will last for maybe a day, maybe not even that if you're using it a lot. So the last thing you want is for the phone to die and then you can't get your alerts. And the other great thing about smartphones is you can actually access the incident details on your phone, various monitoring tools, or if you have email, you can get the details right on your phone. And at night, I believe iOS 6 now has a feature where you can send your critical alerts to Ring and all other calls to go to Do Not Disturb, to silent mode, to voicemail. And Android has this feature also. So another reason why you kind of want a smartphone in this case. Another thing that you need to do a great job at on-call is you need mobile internet, like a 4G or 3G device. This will actually improve your life drastically because think about not having this. You have to either be at work or at home or somewhere where there's reliable internet. And getting from point A to point B, you have to do it quickly, just in case you get paged in the middle. You can't like be on the road for too long. It just sucks. So having one of these devices here, either a 4G hotspot or a 4G USB modem, or even tethering on your smartphone, can actually drastically improve your on-call experience. You're stuck in traffic or you're on the road, you can pull over, connect it to your laptop, and log in and start debugging and fixing problems. And the other thing is this helps. It's good for the team also because it helps reduce incident response times. If you can connect to the internet from anywhere, you get on the issue much faster. So at PagerDuty, we use a combination of 4G hotspots and USB modems. Some people have tethering on their phone as well. And of course, don't forget your laptop, because if you just have the device, what are you going to do with it? Another useful tip for on-call at the person level is to set up your alerting system such that it pages you multiple times. So for some people, they're very heavy sleepers. I'm one of those people. So here's an example of a notification chain that is effective for heavy sleepers. It sends you an email and an SMS right away. A minute later, a phone call on your cell phone. 5 minutes after that, another phone call. 5 minutes later, yet another phone call. Let's try the landline this time, assuming you still have one of those. And then in another 5 minutes, the last and be-all, end-all escalation phone call to the girlfriend. That will get you motivated to wake up and respond to the issue. And here's a bonus tip. You can also get a vibrating Bluetooth bracelet. This is great if you have a spouse who doesn't want to get woken up whenever you get paged in the middle of the night. So this thing will connect to your phone. You put your phone on silent, and instead of the phone ringing, it actually vibrates on your wrist and just wakes you up. If you want to get one of these, just search for vibrating Bluetooth bracelet on Amazon. You'll see those. So next, let's talk about on-call at the team level. So one of the kind of core things that you want to do here is you do not want to send alerts to the entire team. There are multiple problems with doing something like this. Let's say you wake up, you send an alert to all 5 people on your team, and everyone wakes up, but the problem could have easily been handled by just a single person. So now you have 4 people who just got woken up and 1 person who actually fixes it, and you impair the entire team's productivity for the next day. And even worse, what happens in these types of scenarios is there is no clear ownership, there's no responsibility. It goes out to the entire group, and nobody. You can get into cases where everyone's thinking, I'm tired, I'll just let someone else handle it. And in that case, the issue could fall through the cracks, and you can end up just not, big outage, a few hours if that happens. Of course, it's actually a little more complicated than that. I mean, sometimes it is justified to send alerts to the entire team. Of course, this is for like the big, Sev 1 type issues where you need all hands on deck. That's when it's okay. Sev 2s, try not to. I mean, you can have 2 people if you're worried that 1 person isn't enough, but don't, try not to send it to the entire team. Another good practice for on-call is to use and set up on-call schedules. I mean, if you think about it, you have multiple people on the team. If you're not going to send the alert to the entire team, you're going to have to send it to 1 or 2 people. And how do you determine who to send it to? Well, I mean, it's pretty simple. Just set up a schedule for that. A good, simple way to get started is with a rotation-based schedule. So, set up a weekly schedule. I'm on call for this week, then it's Bob, then it's Alice. It just kind of rotates through the entire team until it's my turn again, and so on. This way, depending on the size of the team, I'm only on call for, say, once every 4 weeks, once every 5 weeks, and I can have a life the rest of the time. If you have teams spread across multiple geographies, there's actually an even better way to do it. Set up follow the sun schedules. So a common case there is you have a team in the US, you have a team in India, and the US guys are set up to take the day shift, like from, 11 a.m. to 11 p.m., and the India guys take the night shift, 11 p.m. to 11 a.m. And then this way, nobody gets woken up because of the time zone difference. In fact, this is actually a good motivating factor to hire some guys that are remote, that are in a different time zone. You end up with this. So then you get to the question of what happens if the on-call person just doesn't respond. I mean, this can happen for lots of different reasons, like your phone's dead and you just forgot about it, or you sleep right through the alert, you leave it on silent, you get to somewhere where you don't have cell phone coverage. I mean, people make mistakes, and this will happen. So what you really need is you need redundancy in your on-call if you really care about uptime. So what you want to do here is you want to set up multiple on-call levels with automatic escalation between them. So a kind of a simple way to start is 2 levels. Have a primary on-call and a secondary on-call. If the primary person doesn't answer within 15 minutes, the issue gets automatically escalated to the secondary. And by the way, this works great with scheduling too, because the primary can be set based on a schedule. Let's say, schedule of 3 people, you put the primary, and then the next person in the schedule goes as a secondary, and they kind of rotate through as primary, secondary. Actually, I would actually recommend that you set up yet another level here. This is a good way to do this is to put the entire team on level 3. Now, I said that don't page everyone at the same time in the team, but in this case, I think it's justified. I mean, you already tried the primary, you already tried the secondary. You got to do something. Let's just send it to everyone and see what happens. I mean, someone's got to take care of it. And even better, put management on the on-call chain. I mean, this is a good practice. They might grumble about it, but if you think about it, the managers or directors for a team are ultimately responsible for the team and the systems. So it's not that much of a stretch that they should be on call. Obviously, not as primary or not even as secondary. What you want to do is something along the lines of have a level 4 where the managers are on call. And the great reason for doing this is that now with management being on call, the engineers are even more motivated to actually pick up the issue, because otherwise they'll end up with a manager giving them an angry phone call or chewing them out the next day because they didn't do their job. So this is how Amazon did it. Actually, my team at Amazon didn't even have a secondary. It was just primary manager, and the issue would escalate all the way up the management chain, all the way up to the CEO. So pretty extreme. Another good practice is to put software engineers, the people who are actually writing these systems that go down all the time, on call themselves. I mean, this is a little bit similar to the DevOps model, where devs and ops work closely together. The philosophy here is that devs need to own the systems that they write and engineer. And if you put them on call, they're going to be a lot more motivated and a lot more incentivized to actually fix the problems that are causing them to wake up at 4 a.m. And this is what we do at PagerDuty. This is what Amazon does, and more companies are adopting this model. And another very good practice is to actually measure on-call performance. I mean, you know the saying that you don't improve what you don't measure. So 2 metrics here that you want to measure are mean time to response, like how quickly is your team responding, and you can do this at the team level. You can also measure this at the personal level, like how quickly are individual people responding. And another thing you want to measure is the percentage of issues that are escalated. So you kind of want the percentage to be pretty low, kind of in the 5% or less range. I mean, people sometimes make mistakes, so you have to allow for that. And the other thing you should do is you should set up policies to encourage good performance. So one of these is putting managers on the on-call chain. It kind of provides that, a little bit of a fear factor. You don't want to get it, you don't want issues to get escalated to the managers. Another thing that you can do is kind of like provide bonuses and incentives for people to do on-call duty in the first place. So this is something that Google does. They give you a bonus if you do on-call, and people actually volunteer for it. So it's working out fairly well for them. There's another thing that you can do here. You can set up a network operations center. I mean, I'm sure you guys already know what this is, but it's a room that's staffed 24/7 by ops people generally. Lots of monitoring dashboards, so you can quickly see the health of your systems across all of them. And then people are kind of on standby, kind of always on call to fix issues as they happen. So the great thing about NOCs is that they really will help reduce the mean time to response. I mean, you're no longer having an alerting system paging people at home. They're in the same room, kind of focused and on the job already. So this will reduce the mean time to response. It can reduce it to under a minute. A red light starts flashing, or some pager will go off, and you'll know, and you'll be right there at the computer to fix it. But there's downsides as well. It's not all rosy. Not running a NOC is really expensive. I mean, you need to staff it 24/7. You need to have basically 3 shifts of people and weekends. And in order for this to be worth it, you need to train NOC staff to actually fix a good percentage of the issues that happen. If you have a NOC where the NOC staff, all they do is escalate to the next level, then all they're doing is they're being a human alerting system. And they're not really providing any value in that case. So as you scale your organization, you may want a hybrid model where some issues, some really, typically Sev1 type things, you want them to go to the NOC because you really care about that response time in that case. And then for other issues, you want them to go directly to the teams, to the individual teams that own those systems. And as you scale your organization, the NOC is not going to be, you have like thousands of different systems that are all, service-oriented architecture. You saw the diagram for Netflix. Netflix doesn't run one giant NOC across everything. They actually do a hybrid model where they have a NOC for the, Sev1 type issues, and then they have teams that own their own issues, and they set up their own monitoring. So let's look back at the critical incident timeline, the alert, investigate, fix. And let's zoom in on the alert portion a little bit. So if you think about it, alert can be actually divided into 2 pieces. The first piece would be the alerting system frantically trying to get a hold of somebody. And the second piece is the engineer actually, once they get the alert, getting to a computer and logging in and connecting to the internet, connecting to the VPN and all that. And how do we reduce each one of those components? Well, we can minimize the first component by doing a better job at alerting, using phone calls and SMSs and pagers, and just making sure that people will actually wake up in the middle of the night, alerting multiple times via all of those channels, or failing all of that, escalate, or escalate to the management as well. And how do we minimize the second part? This is where we talked about providing 4G sticks and devices to people such that they can connect to the internet from anywhere, and other common sense stuff like setting the ringer loud on your phone such that it will actually wake you up in the middle of the night. So now we get to the research and fix stage. This is also known as the mad scramble to figure out what's wrong and fix it. How do we reduce this? That's a good question. So one very good practice here is setting up an emergency ops guide. So every time you encounter a new failure, you should document what happened and do a root cause. This is basically taking a root cause analysis and kind of throwing it up on a wiki. You want to document the symptoms, you want to document the research steps that you took, and you also want to document the fix that ultimately fixed the problem. And of course, one aside here is you should make sure that your wiki doesn't also fail when your systems fail. Like, let's say you host your wiki on Rackspace and your whole all of your other systems are on Rackspace and Rackspace goes down. well, now you're trying to fix it, but you can't even get to the wiki. So yeah, put the wiki somewhere else or have it hosted by Confluence or whatnot instead of trying to do it yourself. So this is actually our emergency ops guide at PagerDuty. This is just a table of contents. The actual guide, just you have to scroll. It didn't fit on the screen. And this is a specific incident in the guide, a database primary failure. So it kind of documents the symptoms. Like for us, if the primary database goes down, every page on the site 500s. So that's one of the symptoms that you know that the database is down. And then there's a procedure on how to fix it. I don't know if you can read that, but it says you need to do a database flip ultimately. Of course, you can try to log into the database server and try to figure out what the problem is, but if you can't fix it within a reasonable amount of time, do the flip. Of course, as you're documenting all of these procedures, don't forget that you need to take time to automate fixes. Like if you're doing the same process over and over and over manually, you're doing the same thing like a database flip manually all the time, maybe it's time to automate that. I wouldn't necessarily encourage automating everything. Some things are inherently risky, like a data center flip may be risky. So you might need some human intervention or some humans watching it to make sure that it's executing correctly. And the other thing you want to do is you want to add some more fault tolerance, like look at re-engineering the system such that that failure doesn't happen anymore. So one example that we have is PagerDuty. It started with a MySQL database, and we ended up with failures where the data center would go down on the primary. It was actually MySQL replicated from primary to secondary using synchronous replication. And if the primary data center went down, we had to do a flip process to the secondary. That usually took between 10 and 20 minutes. It involves someone actually getting to a computer, debugging the issue, and then actually running through the step-by-step guide. So 20 minutes is actually not too bad for doing all of that. And then other problems would happen, like the database, the primary server would get borked in some weird way, and then again back to the flip. So we ultimately saw that this was happening. It happened like twice last year, and our uptime requirements are such that we can't go down for 20 minutes at a time like that. I mean, we're delivering alerts for our customers, and us going down is bad. So we ultimately decided against automating that flip fix. The reason we decided not to automate it is because it's actually a very risk-prone process. Like a database flip sometimes doesn't work, and you don't know why. So we instead decided to kind of re-engineer and find a different solution. So switch off of MySQL onto Cassandra, which is a multi-node data store that doesn't require any flips. Nodes can go down up to a certain point, and you don't need to do any flips like that. So, of course, another thing that you want to do to kind of speed up the research and fix phase is get the right tools. Tools to help you diagnose the problems, as well as tools to help you communicate better. So, as we talked about, diagnostic tools include monitoring systems, metrics, and dashboards, as well as tools that help you search for problems faster. So, like for example, Splunk will help you search across all of your log files in real time across your entire infrastructure. And then these are tools that help your team communicate efficiently. These are very, very useful in high severity, Sev1 type issues. You want something like a conference bridge or a Skype chat where people can talk to each other and kind of help each other to figure out the problem. Or you can use something like Google Hangouts as well. And you want a chat system. We use HipChat, but a lot of people prefer Campfire. So something like that where you can talk to your entire group and work your way through these critical issues. And that brings me to another very important best practice, which comes up in Sev1 issues, having an incident commander. So this person is generally a senior engineer, and what they do is they basically provide leadership and are in charge of the situation. So if you can imagine in a Sev1 type scenario, you have 10 people on a call. They're all kind of doing random things and trying to figure out what to do. The commander kind of keeps things organized, directs people to do things, and helps save time to make decisions. You don't want to end up in a case where you get analysis paralysis. You don't know what to do. So this person will help guide the team, and is generally, like I said, someone senior who has seen it all before and kind of has a good sense of what to do and what not to do. And that's it, actually. So do you guys have any questions?
I have a question.
Mm-hmm.
I work for a company which does everyone hear me without the microphone? It's just scary to talk to the microphone. Oh, video. Hello. So I work for a company which has about 15 million customers. We have about 400 IT operation staff, and we have about 20 people on duty 24 hours a day. And the one of the problems we have with contacting right person to solve or fix the problem is that we have 20 teams, and every team has their own incident procedures. They have their own ways or their own levels of criticality for different services. So you're talking about best practices for, for different severity levels of problems.
Mm-hmm.
But what if you have many teams with different views on how critical the service is? Because we, do suggest to have one way to categorize services across all teams, categorize severities across all teams, or really allow teams to have their own severity levels and ways to contact them.
Right. I would actually think you want to kind of bias towards having a standard set of severities, and with some wiggle room, of course. Like like I said, defining them based on business impact is a good way to go, because that way it can provide a common structure across everyone. And ultimately, if you use the same numbers, like 1, 2, 3, 4, and 1 is really bad, and 2 is bad, and 3 is it's not critical, 4 is not critical, and everyone agrees to that, then you already have a common structure to categorize things across everyone. Okay. Any other questions? No? Well, just a quick shameless plug. I mean, if you guys are running ops teams, you should check out PagerDuty. That's what we do. I mean, we manage on-call and do the alerting side. It's a little bit like a ticketing system. The tickets are, we call them incidents, and they're generated by monitoring tools. So like Nagios sends errors into PagerDuty. They become incidents. They get assigned to the right person, and that person is paged via a variety of methods. If failing that, it escalates to someone else. We have on-call scheduling, all that good stuff. So we kind of, built the tool based on how we want on-call to work. And we're also hiring. So if you're interested, ops positions, engineering positions, stuff like that. We're based out of San Francisco. All right. Thank you.
All right, thank you, Alex.